So today I will be doing number 2 of our normal incidence problem for EE140, and the problem is as follows. A 159 MHz RHCP, or right-hand circular polarization, electromagnetic wave incident normally along the z direction from air onto a lossless dielectric medium, and the constant for the dielectric is 4 when z is greater than 0. Such that E0I 00 at the origin is 2 volts per meter along the x direction, and it's asking us to write the incident EI and reflected ER wave expressions. What is the polarization state of the reflected wave, and what is the reflected power and transmitted power in dB? Well, the first thing I like doing for this problem is we have a whole bunch of information, so I just kind of want to see what's important. Well, it is given, the frequency is given, which is very important, and it's right-hand circular polarization, so we have to use our right hand later on. And it's also stated that it's incident normally along the z direction, and it goes from air onto a dielectric medium that has a dielectric constant of 4 when z is greater than 0. And it's also stated that E0I at 00 is 2 volts per meter along the x direction. So I'm just going to draw what we know first. So since it is stated that the dielectric constant is 4 when it's greater than 0, I will just make this axis z, just to make things more simple. You can draw it however you like. And then it's also stated that E0 of I along the x direction is 2 volts per meter. So I will just make this axis x. So it says that when z is greater than 0, which is right here, the dielectric constant is 4. So on this side, the dielectric constant is 4. And that means that this side has to be air, which means the dielectric constant for air is simply 1. So just getting to know, just figuring out my axes, what direction will y be? Well, right hand rule. So x, my down points in z, so y comes out. Just to write that down. It's always good to know your directions. So in this case, x, y, and z, y is coming out of the paper, and then negative y is going in. Then it also states that E0 of I at 00 at the origin is 2 watts per meter along the x direction. So let's just draw that. That is not a good color. Let's see. So that would just be my E0 of I, which is 2 watts per meter. Then it is also stated that it goes from air onto a lossless dielectric medium. So it goes from this direction to this direction, so this direction, which means that that is essentially our k vector. So k will look something like this. K, I. This is our incident electric field. And just to note that this is Ki is along the z direction, just as stated in the problem. Hey everyone, I just wanted to add in another way to draw or represent the wave. I drew it like this when I was doing the problem, but you're also able to draw it like this. This, I think, is a more proper way to draw it, and this is just a very general way to draw it. So, like the problem said, this side is greater than z, so that means that ER is equal to 4 when z is greater than 0, and this is the incident electric wave. EI was given along the x direction, and we know that the wave is going from one boundary to another boundary, so that means that Ki is going in this direction. And we can also say that the transmitted is going the same direction, but reflected, the K is going the opposite direction. And you can get H by simply doing the right hand rule. So if you point our thumb in K and E this way, then H is going out of the page. We can also do the same for the reflected. If K is going this way and E is going up, then H is going into the paper. And the same rules apply to transmitted, like incident. So I just wanted to give you another option on how you would draw it. Well, now that we drew everything, we can use what we have to write the wave expressions. So I like writing down the general form for a wave expression, which is simply the direction that's going in, its magnitude, and then also its phase, and then the unit. And for electric field, it's simply V over M. And if you wanted to get even more specific, if you look at the plane EM waves PDF that's on Canvas, the formula for a right-hand circular polarization wave is actually given. And that's simply just going to be E R T is just equal to X hat E naught cosine omega T minus BZ plus Y hat E naught sine omega T minus BZ. But even if you don't know this specific equation, you can always solve this yourself because most information is given to us. So, writing down what we know. So, we know that E naught of I is actually at 2 watts per meter along the x direction, which means that it's going to be in the x direction times 2, because we have 2 watts per meters. And then it has to be cosine because at time is equal to 0, we do have an electric wave. If it was 0, then it would be sine, but in this case, it's cosine. Let's reiterate, because we have a non-zero value, cosine of 0 is going to be 1, while sine of 0 is equal to 1, so sine can't be the answer, can't be here. And then times omega t, and the question is, what is omega? Well, we can get omega relatively easily by using the formula. Omega is simply 2 pi f, and f is given here, 159 megahertz. So omega will simply just be 2 pi times 159 times 10 to the 6. 10 to the 6 comes from the mega. And this will just give us 9.99 times 10 to the 8, and if we round up, omega is simply 10 to the 9. So you can just write this in our equation, 10 to the 9 t. Now the question comes, and what is k in this case? Well, we can figure out k by using omega. Omega, if you guys remember, is ck. And then solving for k, we get k is equal to omega over c, which is 10 to the 9, as we saw before, divided by the speed of light, or 3 times 10 to the 8. Doing the math, you will get 3.33. And this will simply be a k. Always remember, the k that's stated inside will be the opposite of what we solved. So it will just be negative 3.33 in the z direction. I'll write z right here also. So this is just our E1. Now for E2. Well, E2 can be solved in a similar fashion. So let me just get a new piece of paper. So since we know, we'll write it down first, ERT is simply equal to x hat 2 cosine 10 to the 9t minus 3.33z. I simply just copy down what we had. Now we just need to find the second part, plus something here, which will be in the same form. But the question is, what direction is this E2 going to? Oh, also remember that this is actually our incident. Let's just state more specifically. So to find it, I should just be draw what we know. So just be drawing. We know that at time is equal to 0, it is on the x-axis. This is x and this is y. That means z has to go into the paper because x, y, and z. And in this case, that means our k is also going into the paper. I like orientating this graph so that my thumb is either into the paper or out of the paper because it feels more natural to me, but feel free to do whatever you like. So in this case, because it's right-hand circular polarization, we can figure out which way it's going to go. Well, in this case, since my thumb is going in and my E1 is on the x-axis, my fingers curl this way. So it's heading towards y. So when t is greater than 0, it will go this direction. All that means is it will be in the y hat direction. It will be in y hat, and the magnitude will be the same, and this time it will be sine, and then everything else will be the same on the inside. Watts over meter. And this answer will simply be our incident electromagnetic wave. Now that we found our incident, we can also find our reflected. Since we know we have two mediums where it's air going to a dielectric medium that has a dielectric constant of 4, that means we have two index of refractions, N1 and N2. To find the reflected, we can simply use gamma, which is also known as the reflection coefficient, I mean. To find our magnitude for the reflected. Because the form for this is simply going to be N1 minus N2 over N1 plus N2, which is just going to be also equal to EOR over EOI. So N1 is simply equal to 1, and N2 will be the square root of ER, which is just equal to the square root of 4, or equal to 2. So gamma will simply just be equal to 1 minus 2 over 1 plus 2. Which will just be negative 1/3. Yeah. And then we can just equate it with this side right here. E over R, E naught R over E naught I. And we know what E naught I is because we solved for that, because that is a given. E naught I is simply just going to be 2, which is what was given to us. So negative 1/3 would simply be equal to E naught R over 2. That means our E naught R would just be equal to negative 2/3. And this is our magnitude for reflected. So keeping that in mind, we have EOR being equal to negative 2/3. We can now find our wave equation. So the electric field for electric wave reflected, R of t, is just being equal to, we can just simply copy what we had before, x hat, and then let the magnitude deal with the direction. We can assume that the reflected electromagnetic wave is going in the same direction as the incident, and we will let the magnitude deal with the direction, negative 2/3. Times cosine, just copying from what we had before, right here, times the same thing on the inside, 10 to the 9 t. But in this case, what will our k be? Well, we can use the formula for that will be kr is simply equal to negative k naught z hat, where negative k naught was simply negative 3.33. So negative 3.33, negative on the outside, times z hat will simply just give us 3.33 z hat. Which means that it's going in the opposite direction as the incident k. So plus 3.33 z. Now finding the E reflected 2, let me just rewrite this top part so it's more clear. Plus our y hat times negative 2/3. We can just copy what we had before, but this time we just have to change the magnitude again, and sine, and everything else will be the same on the inside, and 10 to the 9th t plus 3.33 z. And this would simply be our ER, a reflected electromagnetic wave. So we found the ER and EI. So now let's just figure out if ER is RHCP or LHCP, or right hand or left hand circular polarization. And the same method can be used to figure that out. I'm first just going to draw it on the axes. So in this case, E1 is facing on a negative x hat direction. Negative coming from the negative 2/3, which came from a magnitude. So if I call this the x, y, then z will be going x, y, going into the paper. That means k, which is on the negative z, will be coming out. So all that means is it's gonna be in a negative x hat direction, which is this way. At t is equal to 0. And then it goes to negative I hat, negative coming from the magnitude again. So if we know that this is a negative y, it will go here, looking at our ER equation. So if it will look something like this, then t is greater than 0, it's not moving this way. And again, this was we know this from looking at this equation because it's a negative y hat, negative coming from the magnitude. So now we simply just use our right hand or left hand depending on which one will fit this diagram. So let's just start with our right hand first. So my thumb points in the direction of K, and then I'll lay my fingers on the E1 and then curl. And that is not the way that we want it to curl. We want it to curl the other way, which means it has to be a left hand. So again, using my left hand, my thumb points at K and curls. And yes, it's definitely going to be a left hand, which means that this is a left hand circular polarization. So again, you can just check by using your right hand or left hand. Our right hand did not work in this case because it's curling on the wrong way, but our left hand works. So that means it's a left hand circular polarization. Now the problem's also asking for the reflected power and transmitted power. So let's just first find the reflected power. Well, reflected power is simply PR over PI, are representing reflected and incident, which is simply just going to be gamma squared. And gamma was solved before, which was gamma was simply -1/3 as solved before. So, plugging it into this equation, we have -1/3 squared, which is just going to be 1/9. Now, plugging this in your calculator, you will get something like 0.111, which is just simply 11.1%. Now, converting this to terms of dB, which was asked in the problem, we just plug this into our equation. So 10 log of gamma squared is simply going to be 10 log of 1/9, which is just equal to -9.5 dB. Now finding the transmitted power, which is PT P over PI is just equal to 1 minus gamma squared, which is just going to be 1 minus 1/9, because you solved it right here, will simply be 8/9. Now dividing this, you will get about 88.9%. And please note that this equation only works for lossless power. So converting this to dB, 10 log of this of 8/9 will just be -0.5 dB.